my main tenet of my lab is to convert organic waste into, for instance, a fuel. So something that's not useful, make it into something useful. Environmental engineers have often done that in the past by treating wastewater. They do that with an undefined mixed culture. We call it undefined mixed culture. Basically, it's a culture that is very diverse. Okay? For instance, think about as your gut. You know that there's a very diverse community in there with a lot of different bacteria and organisms, microorganisms. So that's what they're doing. We do that, but now we want to make, for instance, a fuel. We want to make something useful. Those you typically use anaerobic environments. So this is an environment without oxygen. We use a tank, very large tank, and we're feeding the organic waste typically in a slurry format or into a wastewater type format into a big reactor, where you there have bacteria and archaea, for instance, convert wastewater in a methane gas that then can be used in a generator to produce electricity, or could be directly used in a boiler for fuel. Okay? So you can immediately see that you have something that wasn't that useful that needs to be treated at the same time. That's costly to do. But if I can make a value, then I can take part of the cost of this treatment that I have to do anyway, and maybe use that to make something out of it, right? It doesn't always have to be economical, because I have to treat anyway. So if you, for instance, look at the brewery, do you guys like beer?
Yeah.
Yes. Okay. And you think about the brewery as, you know, the big tanks with fermenters, they make beer, right? You don't always think that they produce actually quite a lot of wastewater. That wastewater needs to be treated. You cannot put it in the river untreated. So most breweries have very large tanks, and they make methane gas. That methane gas then is pumped back to the brewery, where it's producing in a boiler some of the heat that's necessary. So like there's once, for instance, a brewery just north from here, and they have a big digester, and they offset 20% of their natural gas with the methane that they make into their digesters, right? So again, it's creating value from something that otherwise would just go out in the sewer system. Okay, there's one technology called anaerobic digestion. You can do that, for instance, with cow manure. Around here in Cornell, we have a lot of cows, dairy cows. So that waste goes into a digester as well and makes methane gas. But methane is not that valuable. It's actually the methane cost, the cost of natural gas, which is mostly methane. It's very low right now. So often it's not economical to build such a big installation to make just methane. So we look at other things in the lab, and we're building upon that to use these undefined mixed cultures to make something else. And one of the things that we're interested in is carboxylates. And carboxylates are acids, and maybe some of you know about it, like acetic acid. It's like vinegar is one of those. Vinegar has 2 carbons, so it's a carboxylate or an acid with 2 carbons. But there's other ones like propionate, butyrate. Propionate has 3 carbons, butyrate has 4. And we're interested in making a little bit longer carboxylates with 6 carbons, and that's has a higher value, and then you can use that as a chemical. So again, it's taking a waste, converting that into something that's more valuable, even than methane. So that's what